one measurement is degrees. You guys are very used to degrees within trigonometry, okay? Um, degree measure is simply 360 degrees in a circle. And so if I were to draw exactly 1 degree, that would be a really small sliver, huh? It would be like this big. Or 1/360th of the circle. Right? You okay with that? Everybody with me so far? What's this spot here? We always start with this being 0 degrees. We always start with that spot on the x-axis being 0 degrees. So we got 90. What would be here? 180. What would be here? 270. And then all the way around again would be 360 degrees. So that's kind of how we mark off our degree measurements. So if we say that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, you can see that different degrees fall in different quadrants. So what quadrant does 155 degrees fall in? Second quadrant. What quadrant does 300 degrees fall in? Fourth quadrant. What quadrant does 2 degrees fall in? First quadrant. And what quadrant does 225 degrees fall in? Third quadrant. Okay. Now, radians are different. And you'd say, well, in order for me to have an idea about radians, I would want to know how many radians equal a degree. Well, that's tough. For example, how many feet are in a yard? 3. How many kilometers are in a mile? Yes. It's about 1.6. We do know this for sure. See if you guys remember this. How many centimeters are in 1 inch? 2.54 exactly. And from that measurement, we can then come up with all the rest of the transition. So I will show you what a radian is. This is the big idea. And every day from this day forward, you'll be seeing new material. Okay? So this is something you have to try to comprehend inside your brain. I'm going to say that that is the radius of the circle. Everybody okay with that? Now, here's what I'm going to do. I am going to draw an arc around the circle. Don't draw that one. Okay? This arc, how do you think it compares to the length of the radius? Do you think it's longer than the radius or shorter than the radius? Longer, considerably, right? I need a volunteer who thinks they kind of want to help me out here. You want to help me out? All right. So you tell me when I've drawn an arc that is, you feel, the same length as the radius. Are you ready? I'll go slow. Right there? What do you guys think? Tiny bit longer? Okay. I think that's pretty good. What do you guys think? We'll just stop there. I would say that then this length would be R, and the arc length would be R as well. When the length of the arc is the same length as the radius, that is 1 radian. 1 radian. One radian has an arc length the same as the radius. So this angle that we will call theta is 1 radian. Theta is the Greek letter for TH. It's actually spelled THETA, or in Greek, it's spelled like this. Theta, Greek letter for TH. Instead of giving a T and an H, they put the two together to one letter. And it represents an angle measurement. So here, theta was equal to 1 degree. Here, a theta is 1 radian. We show degree symbols by putting that little degree marker on it. Here, we don't put a degree marker on it, okay? Now, here's the big question. How many radians, how many degrees fit in a circle? 360. How many radians do you think fit in a circle? Take a guess. 8? Anybody else? 6? Any other guesses? Okay, I think 8 and 6 are pretty good guesses. I'm going to try to draw this out. That'll be our first radian. And I'm going to draw this to the very best of my ability, okay? That'll be a second radian. And that'll be a third radian. It just stops short of 180. That's a fourth radian. That's a fifth radian. And that's a sixth radian. Leaves a little bit of a sliver left over. Do you know how many radians fit inside a circle? Aha moment should come on at some point. 6.28 radians in one circle. How many radians fit in a half a circle? Pi. There are pi radians in a semicircle. There are 2 pi radians in a circle. Is that new to you? It's actually not. Watch. What's the formula for circumference? The distance around a circle is 2 pi radians, isn't it? Look familiar, huh? So this is actually something we've already known. We just haven't understood it in this way. So your objective today is to be able to convert between degrees and radians. So if you want to go from degrees to radians, here's what you do. You take your angle value, theta, and you multiply it by pi, and you divide it by 180. For example, suppose we have 60 degrees and we want to convert it to radians. We'll take 60 and we'll multiply it by pi and divide it by 180. So let's work that out. I have 60 pi divided by 180. Does 60 over 180 reduce? Both are divisible by 60, aren't they? What's 180 divided by 60? 3. So 60 degrees is the same as pi over 3 radians. That we can write in terms of pi. Suppose we want to go the other way. We want to convert from radians to degrees. I take theta and I multiply it by 180 and then divide it by pi. Let's try an example. Suppose you want to take 270 degrees and convert it to, I'm sorry. Suppose you want to take 3 pi over 2 radians